answer to this question. Direct ಆಗಿ the delta C matrix will write. Okay, so that the delta C is equal to ತೊಂದರೆ ಇಲ್ಲ, ನೋ ಪ್ರಾಬ್ಲಮ್, ಡೆಸಿಮಲ್ ಅಲ್ಲೇ ಹೇಳಿದ್ರೆ ಆಯ್ತು ಅನ್ಸುತ್ತೆ. 0.28 0.08 minus 0.12 0.04 minus 0.03 minus 0.1 minus 0.18 0.84 and 0.02. Okay, that's the delta C, the cofactor determinant. Now, in order to find the cofactor determinant, we have another method. This is something like a shortcut, right? And this method is called as the direct method. Direct method to calculate the delta C value. Okay, now let us assume that the given determinant is of this type. So A1, B1, C1, B2, B2, C2, A3, B3, C3. So now our intention is to calculate the delta C. So we'll talk about the straightforward. Right, so what do we do now? So this is the step number 1. For the given determinant without the determinant sign or the straight lines, write down all the values. So A1, B1, C1, A2, B2, C2, A3, B3, C3. So we'll write it down, then we'll extend this further, right, like we did earlier. Okay, so write this. A1, B1, C1, A2, B2, C2, A3, B3, C3. Then once again, A1, B1, C1. Then A2, B2, C2. So after writing this, first column and the second column needs to be rewritten in the fourth and the fifth column position. So that is A1, A2, A3, A1, A2. Write the second column as well. That is B1, B2, B3, B1, B2. After doing this, eliminate the first row and the first column from this completely. Okay, consider that they are not there. First row and the first column. Right. Now, after this, multiply to get the 3 values of the determinants, like this and this. This, it's a third. So then the second row, third row of the determinant. In the sense, this is what I mean. So we have to write the delta C like this. So this is B2 C3 minus B3 C2, the first one. Then C2 A3 minus C3 A2. Okay, and the third one, this is A2 B3 minus A3 B2. No negative sign number, right? So it's a simple determinant. Go ahead and calculate the next. That is B3C1 minus B1C3, C3A1 minus C1A3, A3B1 A3 B1 minus A1 B3. Second, so 6 values we got. The 7th, 8th and 9th values and the third rows are as follows. That is B1 C2 minus B2 C1, C1 A2 minus C2 A1. Then A1 B2 minus A1 B2 minus A2 B1. So this is A2 B1. So this determinant, if you write, that is sufficient to calculate the required answer. Okay, this itself is a delta C. Right. Now, so let's calculate a problem. So calculate the delta C for the given delta. This is the given delta value. Okay, so this is 0.15, 0.2 minus 0.3, 1.35, 2.17, minus 1.15, minus 3.55, 0.50, and 1.17. Okay, so the first step is write down the coefficients, right? So that is 0.15, 0.2 minus 0.3, 1.35, 2.17 minus 1.15, minus 3.55, 0.5, 1.17, 0.15, 0.2 minus 0.3, 1.35, 2.17 minus 1.15, then 0.5, 1.35 minus 3.55, 0.15, 1.35, 0.2, 2.17, 0.5, 0.2, 2.17. So out of which we have to remove the first row and the first column. Right, now let us write the required determinant directly. So that means delta C should be equal to 2.17 into 1.17 minus of minus plus 0.5 into 1.15, the first one. Then minus 1.15 into, so this is minus of minus, so plus 1.15 into 3.55 minus 1.17 into 1.35. Then 1.35 into 0.5 minus of minus plus 3.55 into 2.17. Moving to the second row, 0.5 into minus 0.3 minus 0.2 into 1.17. 1.17 into 0.15, this is minus 0.3 into 3.55, minus of 3.55 into 0.2 minus 0.15 into 0.5. The third row elements, 0.2 into minus 1.15 minus of minus plus 2.17 into 0.3, then minus of 0.3 into 1.35 minus of minus plus 1.15 into 0.15, then 0.15 into 2.17 is 1.35 into 0.2. Once we simplify this, we can get the actual answer for the delta C1. Okay, so the answer we get is 3.1139, 2.503, 8.3785. Okay. All right. All right. Okay. 325. 0.055. Okay, that's the correct answer. Let's solve another problem. So using the direct method, calculate the cofactor determinant of the following. So delta is equal to, this is root of 3 by 2 minus 1 by root 3. This is 2 by 3 minus 1 by root 2, root of 2 by 3, 3 by root 2, 1 by 2, 2 by 3, and minus of 3 by 2. Find the delta C. So delta C is equal to minus 2.03, etc. 0.71, 1.637, minus 1.8755, 0.287, 0.686, minus 2.659, 0.815. Perfect. Okay, that's right. Let's move forward. Right. So we'll see various usages of the determinants. Okay, so this of determinants. So this is the calculation of determinants are pretty useful in almost every field. So we'll look at one by one. So the first usage is like this. So the area of a triangle, with the vertices as x1 comma y1, x2 comma y2, and x3 comma y3, right? So when we say triangle, we need 3 points, right? So if you know the 3 points, right, for the vertices of triangle, then we can calculate the area directly, right? So the area is nothing but, this is area A. Area is equal to half of the determinant I am supposed to calculate, x1, y1, 1, x2, y2, 1, x3, y3, 1. So if you calculate this, that is the area of the triangle. Okay, so let me write a triangle for our reference. So we have a triangle like this. Let's say this is x1 comma y1, x2 comma y2, x3 comma y3. So the area of this triangle can be calculated by using this. Okay, so let us go for a problem. So the vertices of 3 triangles are given by the point A, 1 comma minus 3. Okay, the point B is 2 comma 8 and C minus 5 comma 21. Find the area of the triangle, right? So what we have to calculate, area is equal to the half multiplied by the determinant 1 minus 3, 1, 2, 8, 1, minus 5, 21, 1. So this comes to be 45. Okay, then next question, show that 1 comma 1 comma 1, 2 comma 2 and 3 comma 3 are collinear. Collinear means they are on the same line, same straight line. So the idea is that we can apply the area under the triangle and we can show it 0 because there is no triangle, right? The area, if you try to make a triangle with these 3 points, the area of the triangle becomes equal to 0 because, right, you cannot form a triangle. So the area of the triangle which is formed should be equal to 0. So if you want to show that, right, the 3 points are collinear, I just have to show that, right? This means the question is, show that the half of 1, 1, 1, 2, 2, 1 and 3, 3, 1, this is equal to 0 is the question. So if this answer comes to be equal to 0, that means the 3 points are collinear, they lie on a straight line.